So we have seen routing with classful addressing, routing with classless addressing. And today we use the routing with the, sorry, not routing, forwarding with the classless addressing, forwarding with classful addressing. We have seen, and forwarding in the sense, delivering a packet to the next hop is nothing but forwarding. And we have seen forwarding with classless addressing. That is what everywhere used today, because everywhere we use classless addressing architecture. And here, if you see this, what this picture represents portion of the internet, part of the internet. There are multiple networks. Internet means interconnection of different networks. So uh, here you can see, as you can see, how many routers do you have here? Here our goal is to construct a routing table for a arbitrary router for one of these four routers. That is our goal, to construct a routing table for a classless addressing. So how many columns would be there in a routing table? At least four columns. Four. Yes. Four. In a classless addressing architecture, router should need at least four columns to be able to forward the packet. That is a mask, network address, next hop, and interface. Okay. So here, as you can see here, this just a moment. Ah, if you take this one, router R2, how many networks it is connecting this router? Three networks. 1, 2, 3. Okay. Yeah, three different networks. What is network address here? It means that assume that here computers are connected. Okay. We are not representing. Do you understand? Okay. Yes. Yeah. Okay. So the instead of putting all those computers, instead of representing, we are representing whole network as a well. Okay. So total how many addresses? What is network address here? Yeah, 220.10.10. Yeah, 0. That is network address. And so there are many. There can be many computers. We don't know how many computers are connected, how many devices are connected. But for sure, this network is connecting all those computers connected here. See how you will be having only one wire leading to this network from this router. But how all these different network computers are connected here using switch, right? So this wire leads to the switch, and switch will provide a ports, and to switch all those different computers will be connected. So here this router is bridging how many networks? Total three. As you can see here, this center network, as you can see, what is the network address here? 144.45.0.0 by 16. As this is a common network that is joining all these four routers, as you can see, what is the IP of M0? 144.45.0.2.2 by 16, which is slash or cider notation. And this is also same. See, for all these different IPs, this IP, for this IP, for this IP, network is same. Can you see? Because they are all, yeah, think of router has three faces. This router has this one, this one, this one. But this one, since it is connected to this network, IP address that it gets should contain that network and the host. Okay. So are you with me? Any questions? Do you have any questions so far? Okay. So we have this, and as you can see here, and this router again joining two different networks. And here, like that, what is this one? This router, this is a gateway router. As you can see, it is leading to the rest of the internet. Okay. So now tell me here, let's construct a routing table for uh let's construct routing table for R2. Okay, router R2. So if you are constructing routing table, how many columns? First one is, yes, mask. Yes. Next column is network address. And another one is next hop. And interface. Okay, interface number or interface. Okay. Here, remember, we should write a router. We should write in a longest mask order. Okay. Why? Why is that? Like I said, if you take any mask, let's say that if I take a mask 0, which matches any IP address, because prefix is 0. Okay. And if I likewise like if you take a mask one, it matches the most of the addresses because suffix is big, right? Do you understand? So we write this from prefix, large prefix to least prefix. Okay, so which is most specific to most generic. Okay, so here if you scan this network, you look at this network, which one is has highest prefix here? 24. And what is network for 24? Network address 220.10.20.0, and next one is 22. And what is network address? 140.21.0.0. 24, 22, another one is 20. Okay, so we have another one, this 22 here. Okay, we can write this 150.31.0.0. Do we have another 24? No. 24, 22, 22, 20, 18. Okay. So what is this? This is the IP of this port. We have this port, which is interface. What is interface here? M1. What is this interface? M2. Each interface will get its own IP, right? For a router. So whatever is here, what is this? This is the IP of that interface. Okay, so and why is this not 144.45.0.5, but why is it 220.10.1, 20.1? Why is that? Because this interface connected to this network. Okay, so that it will get that IP from that that network. Okay, so another one is 20 here, slash 20, which is 200.10.30.0 and 18. Okay, slash 18, which is 120.32.0.0. Another one is 16 slash 16, 144.45.0.0. And what is the last one? Gateway of last resort, which is default mask. What is default mask? Prefix for default mask slash 0. So we discussed that if you use slash 0, it matches all IPs. Slash 0. How many addresses are there? 4 billion. Which means here prefix is, what is a prefix length? 0. When a prefix length is 0, all 32 bits represent the suffix, which means a host portion. So in such a case, whole address space acts as a single block contains 4 billion addresses. Got it? So in such a case, slash 0 means it matches all addresses, right? So slash 0 is what we represent for a default mask. What is a network? We don't know what network is. Okay, and the next hop we will write. Okay, interface on next hop. Okay, here what is this? This is for R2. Okay, so in this different networks, assuming all routers aware of all different networks here, in such a case, mostly routing table would be same in any of the router. No, sorry, don't get it wrong. Mostly routing table, first two columns would be same for any of these routers. Okay, next hop on interface changes. Let's say that if it is 24, what is next hop here? Router R2. For this one we are writing. What is next hop? Next hop is when, so read this way. Destination address, let's we will discuss about how packet given the destination address, how router checks soon, but here let's say that if it is with the mask 24, network address is this one, 220.10.20.0. what is the next hop that router should send if packet is destined for this network? Next hop is nothing here. Why? It is the same network, remember. So assuming packet is coming from here R4, it is indirect delivery. Router moves to indirect this router, and then from here router transfers that directly, because there is no need to deliver to next hop here. It is directly connected. So when packet is being forwarded, at least there will be one direct delivery and the 0 or more indirect deliveries. Indirect delivery, router travels from router to router and finally reaches the destination. Here, since router next hop is, router finds out that this is a network address and the destination is also connected to the same network, so that it doesn't need to send to another router, so that router converts this destination IP belongs to this network to Ethernet address using ARP, and then directly delivers to the destination. But interface, what is interface here? M1. And now 22. So when packet is destined for 20, this network with a prefix 22, what is the next stop here? See, packet is coming this way and reach this router. This router needs to take a decision whether where to send a packet. Yeah, yes. So there is no next stop here. It is directly connected to the one of the network that router is connected to. So next stop is nothing. No, it is a direct delivery. So in such a case, there won't be a next walk. Since it is a direct delivery, but interface is M2. Okay, and now let's go here 22. This 22. When packet is destined for this network, where to send this packet? This router, let's say packet might be coming from this way or might be coming from here. Where to send this packet? When packet is destined for this network 150.31.0.0, it should send to the next stop, this IP, right? So no. Next stop means next station. Okay, this is the router. This is the router. Okay, this is the router sending. See, you are actually, let's for now take a role of let's take a role of delivery. Okay, delivery person. Okay, delivery guy. So when you want to deliver something to the customer, which one should you will check at customer address or your address from where you are delivering? Yeah, so packet is being delivered from router R2, but when it comes to writing next stop, should you write this address or this address? This one R3, because that is the next stop, that is the destination. Next stop. Okay, next stop. So from here, if there is a next stop, it will take a note of the next stop that is relevant relative to this R3. Okay, so here what is next stop address? 144.45.0.4. but interface, when it comes to interface, from which interface to which interface that next stop is connected for R3? 2-inch M0. Okay, so this is R2, and on M0 interface this next stop is connected. So this is like this. When packet is destined for this network, when router gets the next stop address and sends that packet to the next stop over M0 interface of router R2. Okay, now again, so what is the mask here? Flash 20. This is a network 200.10.30.0. And when packet is destined for this network, what is the next stop? Um, 140. Okay, 144.45.0. Yes. For when packet is destined for this network, so what is the next stop? This is where the packet should be sent to, right? So packet should be sent to this next stop over which interface? Yes. Okay, and for 18 also same. 144.45.0.3 and M0. For 16, okay, for 16, it is, there is no next hop, which is the same physical network. The packet that is destined to this network is the same physical network to which this router is connected to, which is a direct delivery. Okay, and see this network address, we represent that network address as a 0.0.0.0 also. Okay, or we write the default here to present that. So which means that it matches any IP, any network that these different, all those entries don't match. So when that is matched, what is the next stop here for router? This IP, right? That is a gateway, default gateway, isn't it? 144.45.0.1 interface M0. Okay, so that is how we construct the routing table for any given router. Yes, default gateway. So see, when this router doesn't know a packet which is coming, it doesn't know the way to send that packet, since any of these routes in the routing table don't match. So in such case, last route will be the default gateway. That is where it will be sent, because default gateway will always be the boundary router, the where it connects the internet and our networks. So here, this is the one which is connected to rest of the internet. So that, see, this router R1 might aware of different networks here. Do you understand? Okay. So, but since these routers, this router aware of these three different routers, including itself, different network, but it doesn't know any network beyond this. Okay, internet. In such a case, we include that those rest of the networks as a default gateway. So anything that is not known will be sent to that default gateway to here, and it will take care of that. Okay, so but just in case, even when it is sent to this network, and this network doesn't even know about that, it will send that to the default gateway of this router. Okay, and let's say that it also failed default gateway, the packets will be lost somewhere. Okay, so this routing table, all these different routers maintain these routing tables in the memory and take a decision about how to forward these packets. So that is how, when I'm talking with you or over the internet, and we are connected, that is how we are connected. The packet is coming from my source to the destination to you, so traveling over from different routers, router to router, and routers take that is very complex. There's a very big path, and routers take complex decisions, where to send, how to send these packets, and this whole thing depends on the routing table. If routing table is wrong, our network is doomed. Okay, so for that reason, there are primarily two types of routing: static routing and dynamic routing. This is classified based on how routing table is configured. If we configure routing table manually, we call that as static routing. And if we do that dynamically using routing protocols, that router will learn itself. In such a case, we call that as a dynamic routing. Okay, so there are many routing protocols that in a dynamic routing we will learn soon. That is a link state, distance vector, protocols are there, and one of the popular one is RIP, and there is also OSP of IGRP and EIGRP. These are different protocols that are used, that routers use to configure the routing table by themselves, so that when you use dynamic routing, there is a less chance of error, because routers take care of uh, routers communicate with other routers in the network, and they themselves exchange the routing tables and construct the routing tables by themselves. And when you configure manually, we need to make sure that we don't make any mistake, otherwise packet won't be delivered. Okay.